In this video, our goal is to decide when two expressions are equivalent. So for this first exercise, we're given sine of minus a. What do you think? Is that equivalent to minus sine of a or sine of a? To explore, we're going to use Desmos. So in Desmos, you can see that I've entered the expression sine of minus a at the top, and then down below I've entered minus sine of a and sine of a. And we want to determine which of those two is equivalent to the first. So when a is equal to 0, we see that all three expressions are equal to 0. But let's change a. Let's say a was 30 degrees. Now we see that sine of minus a is negative 0.5, minus sine of a is minus 0.5, and sine of a is positive 0.5. So we can eliminate sine of a, and it appears that sine of minus a is equal to minus sine of a, but let me go ahead and run the animation and just watch and see. Do they remain the same for any value of a? It appears that they are, so we'll come back and we'll conclude that the sine of minus a is equal to the opposite of sine of a. Let's try a similar one. Which expression is equivalent to cosine of minus a? Here you can see that I've got cosine of minus a at the top, and then minus cosine of a and cosine of a at the bottom. When a is equal to 0, cosine of minus a is 1, minus cosine of a is negative 1, and cosine of a is positive 1. So right from the get-go, we can see that cosine of minus a does not equal minus cosine of a. Those two are opposite in sign, which that might go against our tuition because we just saw that sine of minus a is minus sine of a. It seems like you could just take that negative and pull it out in front. But for cosine, that is not the case. So we're going to eliminate minus cosine of a. And again, we want to double check and make sure that these two expressions are equal to each other for different values of a. So let me run the animation. And we can see that no matter what value of a we pick, cosine of minus a is equal to cosine a. So cosine of minus a, that's equivalent to cosine of a. We say that those two expressions are equivalent to one another. What about sine squared a plus cosine squared a? Which of these three expressions is it equivalent to? So here I have sine squared a plus cosine squared a up at the top. I have the square of sine a plus cosine of a in the next row, sine of a squared plus cosine of a squared in the next row, and the square of sine a plus the square of sine a in the last row. And we can see that when a is equal to 0, all three of these are equal to one another. So let's go ahead and change a. What if a were equal to 30 degrees? In that case, we see that sine squared a plus cosine squared of a is 1, but the square of sine a plus cosine a is about 1.866. So we can eliminate that choice. Sine of a squared plus cosine of a squared is equal to negative 1. We can eliminate that choice because it's not equal to positive 1. And here's sine of a quantity squared plus cosine of a quantity squared. That is equal to 1. So let me run the animation and see. Are these two always equivalent to each other? It would appear so. Now, did you notice something interesting as a was changing? The value of sine squared a plus cosine squared a is 1. And if we change the angle, the value of 1 does not change. So sine squared a plus cosine squared of a is equal to the square of sine a plus the square of cosine a. But maybe more importantly, sine squared of a plus cosine squared of a is equal to 1. And we're going to learn that the name of this particular identity is the Pythagorean identity. Sine squared a plus cosine squared a is always equal to 1 no matter what angle you pick for a. For our next exercise, we have sine of 2a. Is this the same as 2 sine a, 2 sine a cosine a, or sine squared minus cosine squared a? Here I have sine of 2a up at the top and the other expressions down at the bottom. We can see right from the start that sine squared a minus cosine squared a is different. So we're going to go ahead and eliminate that. So it's down to two choices. Is it 2 sine a or 2 sine a cosine a? Let's change a to a different angle. Say a is equal to 15. Sine of 2a is 0.5. 2 sine a is different. 2 sine a cosine a is the same. So we can eliminate 2 sine a. It doesn't have the same value. And then just to double check and make sure that these are the same, let's go ahead and run the animation. And yeah, we can see that no matter what the value of a is, these two expressions are the same. So our conclusion is that sine of 2a is equal to 2 sine a times cosine a. For our last exercise, we have cosine of a plus b. Which of these expressions is equivalent? Again, we'll use Desmos to explore. Up at the top, we have cosine of a plus b, and when a is 0 and b is 0, that's equal to 1. If we scroll down to the other expressions, we see that cosine of a plus cosine of b is 2. That's different than 1, so we'll eliminate that as one of the options. Cosine a sine b plus sine a cosine b, that's out. So is cosine a sine b minus sine a cosine b. But the other two are still in the running. Both of those expressions are still equal to 1. So let's go ahead and change our a and b. Let's say this time we pick a is equal to 60 and b is equal to, say, 45. We see that cosine of a plus b is about negative 0.259. And the only expression that is equal to that is the last one, so we can eliminate the first. So our conclusion is that cosine of a plus b is equal to cosine a cosine b minus sine a sine b. And of course, we could use the animation feature just to see that this isn't coincidence, that it's true no matter what values of a and b we pick. So cosine a plus b is cosine a cosine b minus sine a sine b. And this probably goes completely against our intuition. You might think we would just distribute and get cosine a cosine b, but we didn't. And there's a plus, so we'd expect that our formula would have a plus in it, but it actually has a minus in it. As you're working on these types of explorations at home, you're welcome to use Desmos, or you can use your calculator. You'll just have to pick different values for a and b and substitute them in to be able to make your decision. I hope that helps you out.